Hey guys, good morning all. I think we're good to start. Here's a sufficient number of folks here. Quickly give me a yes in the chat if all of you guys can hear me and see the sublime text. Quickly give me a yes in the chat. Okay, you guys can. Cool. Let's start with today's session. Um, I was expecting last class would be our last class, but I get to know that there is one more class scheduled today, which I was not expecting. But anyways, today is going to be our last class for low-level design course. High-level design will start after this low-level design is completed, and those who are part of the high-level design, that your system design is completed after this low-level design will end. Okay, so that will go in sequence. Now, for this one, I've taken a very specific case study which has been actually asked in the interview. So you would try to mimic the same behavior which have been asked in the interview, how kind of questions are asked and how you can do it. We'll walk through it what we're going to do today. As part of now, we talked about 3 case studies so far in terms of machine coding round, what I've been asked. We've covered our low-level design course, we've done the case studies, we talked about design patterns and everything. The last case study that we did in the last class, which was the important one, which was parking lot design. Okay. It's a really long case study to talk about in terms of parking lot design. What we have to do is we have to create a multi-level parking lot. In terms of that multi-level parking lot, we should have an automated system where you can create a ticket, you can park it, unpark it, and so on and so forth. So I went through these 46 input test cases where we have like 1 for truck, 2 for bike, and n minus 3 for cars, considering n are the slots. And of course, there are multiple floors as well. So we walked through these 46, 48 test cases, whatever that was, and we printed the output for it. 46. Okay. We wrote down the code, we come up with the implementation part. First, this is the motion solution that we have to go for. We understood about the classes, model entities, services, driver class, adapters, slash logic, validations, enums, and service layer logic. So my parking lot, I kept parking lot as one class, floor, slot, display commands, vehicle, and vehicle type, right? When my parking floor is actually the list of floors, floor is a list of slot, and a slot is the ID based upon the vehicle. My models or entities include my parking lot, my floor, my display command, and vehicle. Service logic we have kept as a parking lot service. Driver class is main.java slash driver.java. In terms of adapter logic, we have the parking lot service here. Validations, we kept it like for each floor. First one is going to be for truck, next to be for bikes, rest all are for the calls. And we have FCFS logic here, first come, first serve. Then in terms of the enums, we have vehicle type, and in orchestration controller, we have a parking lot controller and parking lot repository. Now, in terms of the workflow reasoning, we have number one, we need to create a multi-level parking lot system. There will be multiple floors, there will be multiple slots per vehicle in each floor, there will be multiple vehicles as well. Okay. And this is the assumption that we already discussed about. Main class is used for taking the input, and my orchestration will take care of passing it to the service level or implementation level. This is how we implement it. Now, in terms of the entities, from entities we go to service and via the driver class. So we had the parking lot, floor, display, and vehicle. In service, the logic was kept as the parking lot service, logic to find the lowest floor, the lowest slot, FCFS, which we are talking about here. And then we have gone through the code, we have verified with all the 46 test cases here. Okay. A sequence of 46 test cases. That is a really good case study number 3. But if such kind of case studies asked, assume you would be easily given 3.5 hours, because you cannot write all of these cases or edge cases take care within 1.5 or 2 hours to be very precise. So you'll be given 3.5 hours one. The case study which I'm going to start with today, and that's our final class as well. And I also share some notes and resources in case you know about high level design and low level design in general at the end of this class. Yeah, I'll share that. After completing this case study, since this is the last class, I'll share some of the resources that you can refer to in terms of what you want to study or what you should focus more on in terms of interview perspective. Okay. So let's start with the case study number 4. That's what we'll have. This is the syntax that I've been following so far. Before that, any questions regarding the revision until the last class? If not, then we can start with today's session. Everything is clear till the last class? Any doubts, any questions? Okay, I'll take it as a no. Let's start with case study 4 for today. The format that we have done for case studies, we'll talk about the problem statement, mandatory and non-mandatory requirements, options slash monos requirements. Time usually given it's 2.5 hours. Expectation is use the best programming practices and come up with the implementation. You can use ID of your choice. You'll be screen sharing it, writing coding from the scratch. Of course, you can use the libraries. Sample input output will be given to you. You can code in any language. Okay. That being said, we are taking the interview question here. So we'll try to mimic the same scenarios as what you'll be given in the interview, what you need to implement and everything. So this was given by one of my mentees who interviewed for Flipkart, and we'll talk about that. Okay. All right. This question was asked in Flipkart, and the role was for SD3. This was the interview question. Okay. Let's go to the interview question detail. I have the You'll be given a Google Doc kind of a thing. So once I'll share the screenshot, you'll be able to understand how the question will be given to you. We'll talk about that question in detail and then we'll take it from there. Okay. Let me share my screen real quick. I'm back on my IntelliJ. Everybody can see my IntelliJ screen. Just let me know in the chat. Okay. So this was the exact question which was asked. So if you look at this, that is the kind of Google Doc or some kind of a sheet that will be provided to you, mostly a Google Doc, right? So it will contain the input. So it's the question number one, question number two, like this is the part of the question. You'll be given sample input, sample output. You'll be explained with the question, what are the expectations? There will be some bonus requirements, etc., etc., and then you can take care of how to code it. This is exactly how it will look like in the interview, just for your reference. Okay. That being said, let's get the understanding of what this question is, then we can start with the implementation. I'll give you enough time to think of that, and then we can move to implementation. Once we're done with that case study, I can share some resources at the end of the session. Now, starting with number one. What you need to do is, you need to build a ride-sharing application. Let me zoom this a bit so you can see this screenshot. The description, this is as it is, verbatim what it was asked in the interviews. I've not changed any word here. You have to implement a ride sharing application. Now, ride sharing application, you can think of example like, let's say Uber, Ola, or Popa Ride. I don't think Popa Ride is in India, but just an example where you have to pool. I don't know what's car pooling service in India, if there is any. I think there was a Zoom car, if I'm not wrong, quite a long time ago, but I'm not exactly sure. So think of like a car pooling service. Example is not Uber or Ola, because in Uber and Ola, there's an option to share a ride, but car, okay, Zoom car. Yeah, I've heard about that, but I've never used it, so I'm not 100% sure. The carpooling service, what it means is like multiple people put money together and they just share the expenses, like petrol expenses or diesel expenses, whatever that car is, right? Gas expenses, basically. That is what the ride sharing application is. That's what I'm talking about. So it's not exactly an Uber where you'll book it and you will go and you'll pay for the ride. It's not that application. It's that like multiple people come together, they pool the car. Let's say they're going to office together, your colleagues are going to office together, they just share the common expense. Think of that kind of application. That is what ride sharing application is. Okay, just to set the expectation right. Below are the expected features from the system. The application allows users to share rides on a route. Okay, users can either offer a shared ride, means they can be a driver, or consume a shared ride, means there can be a passenger. So two main actors in our system. Users can search and select one from multiple available rides on a route with same source and destination. Okay. And there are certain requirements given. For example, application should allow user onboarding. So there should be a function called add user, and I can add the user details. I can add the basic user details. I can add the user vehicle details. You should be able to offer a shared ride on a route with details. For example, offer ride, and I can have the ride details like that. So ride will have details like what's the vehicle, what's the origin, destination, start time, ride time, available seats. Okay. And it's assumed that ride will not have any intermediate stop. So it will go from source to destination. Then a user can select a ride from multiple rides offered by a selection strategy. Now there can be multiple selection strategy. One selection strategy is a user can select a ride for himself only for one person. A select ride. So there are two strategies, one with the fastest ride, which is the shortest ride time, and one with the reaches earliest end time. So there are two strategies. So we can decide which selection strategy to choose for. Okay. Fastest ride means shortest ride time, let's say 6 hours or 6 hours versus 10 hours. And second one which is the earliest, that is the earliest end time. Find total fuel. Sorry guys. Find total fuel saved by any passenger. So a passenger will save X unit of fuel for shared ride of X hours. So if you drive for 6 hours, you'll be saved 6 units of fuel. So you have to find total fuel saved by any passenger. Find total rides offered or taken by a user. So we should have some kind of a logic to list down the total number of rides or total number of rides offered / taken by a user. Write a driver class for demo purpose will execute all the commands at one place. So that is the expectation, and have test cases. Do not use any database or NoSQL. It's very clearly mentioned. You don't have to think any DB integration. You can keep it in memory data structure. So feel free to use hash map or anything, whatever required. Do not create any UI for application, not required. Please prioritize code compilation, execution, completion. This is the important part. More than optimization, the first part is the correctness of the code. So you are able to compile it, execute, and complete it. Work on the expected output first and then add bonus features of your own. And then we're given some sample test cases to go through. So expectation is number one, make sure you're working on demoable code. So it's working fine. Second, it's functionally correct. Proper abstraction, entity modeling, separation of concerns, divide into models wherever you need to. Code should easily accommodate new requirements with minimal changes. That's extensibility of the code, proper exception handling, concurrency handling in case, let's say, there are multiple people trying to book like the cab at the same time or the kind of car at the same time. How will you handle that? Okay, that is a bonus case. Then they have given some sample test cases that will go one by one. Okay, so there you go. One of the output is incorrect here, so I'll correct it in my readme.md. This is a screenshot, so anyways, I cannot correct it here. But one of the output is incorrect, so we'll go one by one. Okay. So we're given some sample test cases and we are given some sample output as well. So let's go one by one. I think let's start with number one. So we onboard 5 users and focus your attention here. 5 users are: one is Rohan, male, 36. He has a vehicle, a Swift car, and the registration number of the car. I'll just zoom this guy a bit. Okay. Second ad user, Shashank, male, 29. It has a vehicle, Baleno, and we have added the vehicle. Nandini, she does not have a vehicle. Shipra, she has a vehicle. It's a Polo K01, and it has 2 vehicles actually. So one vehicle is a car, one vehicle is a scooty. And Gaurav does not have a vehicle. Now, what are they doing is they're offering the rides, right? So in terms of offering a ride for 3 users, so Rohan offered a ride starting from Hyderabad. Seats available are one. Obviously, Rohan has one car only, which is Swift. Destination is Bangalore. Start time is 25th Jan 2019, 8 a.m. and ride duration is 13 hours. Similarly, there is other ride offer by Shipra, which is going from Bangalore on a scooty. Destination is Mysore. We have the start time and we have the ride duration. Third, we have again offered by Shipra. This time is for the car. Now there are 2 seats available in the car. In scooty, there was only 1 seat available. Again, going from, where's the source? Bangalore to Mysore. Start time is there and the end time duration is there. And then is Shashank offering a ride. So Shashank also has a car and he is offering from Bangalore. So starting from Hyderabad to Bangalore, we have 2. Bangalore to Mysore, we have 2. Okay. All right. Now what we need to do is we need to find the rides for 4 users. So number one, we'll be given the name who wants the ride, will be given the origin, will be given the destination, will be given the strategy, which one will be the correct strategy to find the output. Okay. So let's validate for these 4 test cases. Any questions so far before I go for validating the test cases and expected output? Any questions so far? Okay, cool. Let's quickly go on to the first one. The first question is, or the first test case is, we need to find a ride for Nandini starting from origin Bangalore to the destination Mysore. And the selection strategy is fastest ride. Remember, there can be 2 kinds of selection strategy. Either it's the fastest ride or it can be the earliest ride. Okay. So the selection strategy is fastest ride. That's all we need. So out of these 4 rides, tell me about the rides which are going from Bangalore to Mysore first. Quickly in the chat. Tell me about the ride which is going from Bangalore to Mysore first. I mean, you can tell in A, B, C, and D. I'm not asking the output. Like if there are multiple rides, you can just say A, B, or C, D, and so on and so forth. Which rides are going from Bangalore to Mysore? Come on, guys, quick in the chat. All agree? Both B and C, the one which is offered by Shipra, one in scooty and one in car, both of them are going from Bangalore to Mysore. So answer would be either one of B and C. All agree? Come on, guys, all agree? Okay. Now, what's the question? The question is fastest ride. We talk about the strategy of the fastest ride. So if you look at the fastest ride, the first one take 10 hours, the second one take 4 hours. So which one would be the answer here? B or C? If you look at the dates also, by the way, this one is reaching on 29th Jan. This one is reaching on 30th Jan. So it was not earliest time. It is the fastest ride. Technically, if you take this ride or if Nandini took this ride, she will be there in Mysore before then taking the second ride. But our question did not ask about the strategy for earliest arrival. The question asked for the fastest ride. So the fastest ride is for 4 hours. That's why the output will be 2, C. All agree with this? Any doubts, any questions, anything unclear? Okay. The output will look like this. By the way, the output should look like this. So the first case, ride is given by Shipra with vehicle number 4191. What is the vehicle number 4191? This is the vehicle number 4191, 2, C. Okay. So 41491, that will be given to the Nandini. That's how you'll show the output. Okay, you will not say 2 comma C, you will print the correct output like this. Who gave the ride, what's the vehicle number, and who was the ride given to. This would be the expected output format. Okay. Everybody clear with the first test case? Everybody clear? Okay, let's move on to the second test case. Now, the second test case is Gaurav needs a ride starting from Bangalore to Mysore, and the strategy is earliest ride. So first, let's take step by step. What are the options out of ABCD to go from Bangalore to Mysore? Again, B comma C, only B comma C is what Bangalore to Mysore. Now, what is the strategy here? The strategy is earliest ride. So earliest ride, if I have to pick where the rides given by Shipra, by which duration I'll reach the earliest? If I start on 29 Jan 18, and if I add plus 10 hours to it, that would be like what? 4 o'clock on 13 Jan, right? And if I start with 6 o'clock and then I add, that will be like 10 p.m., right? So obviously, I'll read better in the B case. So what we have to print? 2 comma B is the desired output. And how would you print that? You'd print that in the format. Shipra gave a ride, but with 2 comma B. What is the 2 comma B here? The vehicle ID is 12322. So Shipra gave a ride, vehicle ID is this to the Gaurav. This is how you will completely print it. Everybody crystal clear with second test case? Any questions, any doubt, please ask. Easy? Okay. Let's move on to the third test case now. Third test case, Shashank needs a ride starting from Mumbai to the Bangalore. Out of A, B, C, and D, which flight is going from, or which, not flight, which cab is going from Mumbai to Bangalore? Go on, guys, quick in the chat. The answer is there is nothing or no ride going from Mumbai to Bangalore. That's why the output is no ride found. There is no ride available. And last test case number 4. We need a ride for Rohan starting from Hyderabad to Bangalore, and then the strategy is fastest ride. So first thing first, which ride are going from Hyderabad to Bangalore? All agree? All agree? A and D are going from Hyderabad to Bangalore. So answer would be either A or D. What's the strategy? The strategy is fastest ride. So if I look at the A, it's taking 13 hours. If I look at B, answer is 14 hours. So what should be the correct output here? It's one edge case, guys. Think about it. It's one edge case. Okay. If I look at by the fastest ride, if we look at 13 hours, this is the correct one. But if you look at it, Rohan is the one who is asking for a ride. This is the case where Rohan is offering the ride. If Rohan is the one who is asking for a ride, he cannot be going in this case in the first place. Yes or no? This is the part for selecting a ride. So if Rohan is going from Hyderabad to Bangalore, he could not be the one driving. He's asking for a ride. That's why we got only one option, which is D. That's why 2 comma D is the desired output. Okay. That was the edge case we was talking about. So a driver cannot be a passenger. Okay. And you can discuss that logic with the interviewer. It's not something a very critical part, but this is something good to know about. Okay. Now coming to the next part. These 4 inputs output, everybody clear? And again, for the fourth one also, let me print in case I have not printed it. For the fourth one also, I'll be printing like this. So third one, you'll be printing like no such ride is there from Mumbai to Bangalore. And for ride, this is given by Shashank, the vehicle number to Rohan. Okay. Now coming back to this, question number 2. Any doubt on these 4 test cases or their expected output and etc. etc. The format in which you have to print the output, is that clear? Okay. Now coming to finding the fuel saved. So what we have to do is we have to find the fuel saved. And when we say fuel saved, what do we mean by that is the logic of fuel saved is given here already. Is that for fuel saved, there was somewhere mentioned here. Okay, question 1 maybe. The logic for fuel saved is here mentioned here. A passenger will save X units of fuel. One moment. Passenger will save X units of fuel for shared ride of X hours. Okay. Let me go to your part. For Rohan's side, you mean for the D1? For the D1, we are supposed to print this. Shashank has offered the ride in the vehicle number to Rohan. So ride is given by person who is giving the ride with vehicle number to who is ride the gives given to. That is the expected output. Okay. All right. Now coming to this, find fuel saved. How do we determine the fuel saved? Again, going through the logic. Passenger will save X units of fuels for a shared ride time of X hours. Okay. All right. Sounds good. Let's see the output now. So how many hours Nandini has been in transit for? So if you look at Nandini, Nandini has been in transit for 4 hours, correct? So the number of fuel or number of unit of fuel saved by Nandini is 4. All agree? Nandini was in the ride for 4 hours. Output saved by Nandini is 4 units. Again, going back again. Find total fuel saved by any passenger. So first thing first, fuel is saved by passenger, not by driver. This part clear? Think logically. Okay, think in a real world. Forget about logically also. Um, a driver is anyways driving. Agree? A driver technically cannot save the fuel. A driver is anyways driving. If a passenger joins, think logically, forget about this case study for a moment. If a passenger joins, the whole idea of carpooling is you're saving the fuel, right? Otherwise, you will be going by your own car and then you will be spending that fuel. So once you become a passenger in a shared car or in a shared pool, that is when you are saving the fuel. This logic clear to everyone? As a driver, you are not saving the fuel. When you become a passenger in a pool car, that is when you are saving the fuel. All agree with that? Okay. Same logic explained here. Only a passenger, and it's very clearly highlighted here also, will save X unit of fuels for a shared ride of X hours. So if I am a passenger, I take a ride for X hours, let's say 10 hours, I'll be saving 10 units of fuel. This statement clear to all? Okay. Now we can go to question 2. So who are the passenger first? Nandini was a passenger, Gaurav was a passenger, Shashank was a passenger, Rohan was a passenger. So 4 outputs. Okay. So Nandini has taken the ride as a passenger for 4 hours. The first one, 2 comma C. So that's why Nandini said 4 units. All agree? All agree quickly in the chat. Okay. Gaurav as a passenger, he chose 2 comma B. So it took like 10 hours. So Gaurav saved 10 units. All agree? Okay. 4 units because she chose 2 comma C. So 2 comma C is only 4 hours of drive. Nandini took this one drive, which is by 2 comma C, which is 4 hours of drive. That's how she said 4 units of fuel. Guys, any questions? Anything which is not clear, let me know. This was a ride which Nandini took. This is for 4 hours. Yes, it's mentioned in the question. A passenger will save X unit of fuel for a shared ride time of X hours. It's clearly mentioned here, this part. Okay. Now coming back to this. So Nandini took a ride for 4 hours, a shared ride for 4 hours as a passenger. That's when Nandini took saved 4 units of fuel. If I talk about Gaurav, Gaurav took like 10 hours of the shared ride. That's why Gaurav saved 10 units of fuel. Shashank has got no ride. That's why the output is 0 here. Rohan taken 2 comma D, which is 14 hours. So Nandini 4, Gaurav 10, Shashank 0, 4 and 14. These are the number of fuel units shared by these passengers. Everybody is still clear with this. Come on, guys, click in the chat. Okay. Now the final output. The final part is we have to print for every user how many rides they have taken, how many rides they have offered. So let's go one by one. If I talk about Nandini, Nandini has not offered any ride, but Nandini has taken one ride. So 1 taken, 0 offered. All agree? Come on, guys, quick in the chat. All agree? Nandini has taken one ride, but Nandini has not offered any ride. So offered ride is in the 2 part. So output is 1 comma 0 for Nandini. If I talk about for Rohan, Rohan has taken, yes, yes. Rider can also take ride from others, but not in the same car, not in the same journey, not in the same journey. That's why the reason, if you remember the test case, 3 comma D, in the test case, Rohan was the one driving it. So Rohan cannot be the one who is actually a passenger there. That's why we did not consider the 2 comma A place, even though it is 13 hours and it is 14 hours, but we did not consider 2 comma A because Rohan is the one driving, right? That's why. Now coming to it. For the Rohan part, Rohan has offered one drive and Rohan has taken one drive, which is given by Shashank. So one taken and one offered. Everybody clear with Rohan? One taken, one offered. All agree with this? Okay. Let's move on for Shashank. So Shashank has offered one ride for sure, but when Shashank needed a ride, there was no ride found. Agree? Shashank wanted to go from Mumbai to Bangalore. There is no ride from Mumbai to Bangalore. Shashank offered a ride from Hyderabad to Bangalore, but that was taken care by Rohan. So Shashank has taken zero ride, but he has offered one ride. All agree? Okay. Now the last one. Gaurav has not offered any ride, but Gaurav has taken one ride. This part. Okay. So Gaurav has taken one ride, offered zero ride. Four test case, crystal clear to all. Someone guys quick in the chat. Okay. This is the case study that you have to implement. This is the exact interview question which was asked for Flipkart SD3 role. Okay. You're given the clear instructions. I have given the exact sheet which was shared with the interview. So as a candidate, you know what exactly to expect. This is the sample format that you can print it. And of course, you can change it. This is just an easier way to print the format here. So I'll take this. It's everything that we just discussed right now. And I'll walk through in case there's any questions on the input, output, or anything like that. So there you go. This is your entire problem statement. Okay. All right, guys. Any question on the problem statement? What is the expectation? What we need? Anything like that? Please let me know. Question is clear to all. What are we building? How we are building? What are the requirements of the questions in review? Okay. If everybody is clear, I would prefer to go with the general syntax flow and in terms of whatever we expect in terms of interview. So when I say general syntax, usually it is like this. In your utility, you define what constants and configs you want to keep. Validators, which includes validator service. You can have any REST controller, which will have as your orchestration. And then you can have the implementation to be kept in service implementation. Like this. Okay. Keep this in general format. If you want to modify it, feel free to do it. Coming to my expectations, I'll just scroll down. We'll follow the same format as we followed for all the case studies. So it becomes consistent. My expectation would be this. So provide me what kind of classes you want, what kind of model/entities you think would require in this system design. What services, what driver class, adapter logic, validations, enums, and service layer logic you would like to keep for this. That being said, I've given you the exact question which is asked in interview. So think like you are the candidate, you have to implement it in 2 hours or whatever that time is, and try implementing the same way while giving solutions for this. Anything that is not clear on the requirement, let me know. Anything that you need my input on understanding the question better, let me know. Everybody crystal clear what the case study is, what you need to do. Come on, guys, quick in the chat. Okay. If you guys are clear, this is the expectation which we always follow with. So I'll just give that in the chat. I'll give you due time. Just don't take too much time because I would like to reserve like 15-20 minutes for walking through the next part, which is like resources and everything, along with the code for sure. So I would want you guys to come up with these 8 or 7 points, which is we have followed all the 3 case studies before. Talk me through classes, entities, services, driver class, logic, validation, enums, and the service layer logic you want to keep. Okay. And walk me through it, how will you do it? It's completely fine if you don't want to write the code. I mean, it's difficult to write the code in, I would say, whatever time duration you will have to come up with this part. But do try it after the class for sure. But as of now, I would need these 8 things from all of you. Okay. Based upon your understanding, why do you think these classes are required? Why do you think these entities are required? All those logic I want you guys to come up with. Any doubts in the expectations? Anything which is not clear? Anything you want me to repeat? All good? All right. If everything is good, I've given everything that is written from my end. Just keep this output screen here so that you guys know what form of output you want to print it for your reference. Okay. All right, guys. That being said, it's all up to you now. Please share a message. Please change the message directly to me. Do not message to everyone. And let me know once you guys are done with discussions. Okay. Discussion in the sense, once you guys are done with those solutions, please share the solution. And whenever you're ready to discuss and walk through the code, then we can start with it. Okay. That being said, your time starts now, guys. Please change your message directly to me. Do not message to everyone. Let everybody think through their approach and come up with a solution. All right, guys. Are we good to discuss? Anybody else needs more time? Quick in the chat, guys. Are we good to discuss? Shall we start the discussion now? Okay. Cool. Let's start discussing the solution and then we'll talk one by one. So start with my solution, then we can take it further. All right. For these 8 parts, let's go one by one, the way that I have implemented, and feel free to put your inputs as well and change it. The way that I've used is, number one, we have a user service class, which will take care of the user information and putting the values, for example, their vehicles, etc., etc. We need one for the write service. We need one for the earliest write, and one we need for the fastest write, just to keep those logic correct. What else? We need obviously a write class, a user class, a vehicle class, and a main class, basically a driver class. In terms of our entities or models, what are the models and entities that we have in our system? We have a write, we have a user, we have a vehicle, and we have a service, which will be write plus user. In terms of service, I just need 2 services. One is for the user service. One is user service. It's just user onboarding service, which will take care of creating a user, what kind of car they have, if they're looking for a sharing or they're looking for a driving, so on and so forth. And second is the write service, which is the main one. For driver class, we'll keep a driver.java or main.java, which will take care of the logic, client class logic. In my logic, what do I need to take care of? The 2 schemes. First one is earliest write. The other one is fastest write. In terms of validation, couple of validations to do. Number one, you need to check if the user is present in the first place. That is the first requirement, right? Somebody who is offering a ride or somebody who is taking a ride, first check whether the user was registered or not. Second, check if the ride is valid. Okay. Number three, if there is no, so in terms of ride is valid, the possible scenarios you can do it like source should not be equal to destination. That kind of validations you can put here, like that. If there is no ride available from a source to destination, then you return no ride available. What else? Concurrent request, we are not dealing it at the moment. Not at the moment. Okay. But we can talk about it. Yes, that can be one validation that available seats should be greater than equal to 1. Okay. And what else? And on that note, when we say available seats greater than equal to 1, we also need to make sure whenever a ride is done, we reduce the available seat by 1. In terms of enums, no such enums required as of now. We can see if it were required later, but as of now, I don't think there's any enum required in this case. And this would be taken care by the RAD controller services. Okay. So I'll start with the workflow reasoning and the general flow. We have only one vehicle type. I mean, we don't need a type as such. What we are doing is we are not segregating whether it's a scooty or it's a bike. What we're taking a vehicle, it's a registration number, and that's it. So there's no use case of extending it to multiple vehicles type. There's no need. There's no need. It's a ride sharing application, right? We are not talking about what kind of vehicle we are sharing. What we are more concerned about is we are sharing the ride rather than considering what kind of vehicle only I'm sharing the ride for. Okay. So I'll start with the workflow and reasoning part here, over here, and review. So before workflow reasoning, what is the general flow that we always talk about? General flow is number one, you start with entities/models. Number two, you write services which interacts with these models and among themselves. And number three, you write the logic for driver class. That is how you implement. In terms of workflow reasoning, what do we need? Number one, we need to create a ride sharing application. Right? In that, what we want? We want multiple users. And we want multiple rights. What else? There are multiple strategies to select what kind of ride we want. So in terms of strategies, there are two strategies of now. It can be earliest ride or it can be the fastest ride. Number five. So one more thing to add here, five, and then this would be six. The user which is acting as a rider, they can be a passenger also. So a user can be a rider and a passenger. But one edge case that we talked about in the case of example of Rohan in this, edge case could be if a user is searching for a ride from the same source and destination to which he or she is a driver as well, we don't select the driver as rider. Okay, that was the edge case. What next? Multiple strategies, we talked about it. Anything else to add? Yeah, main class will be used for taking input. What else? Orchestration would be taken care by our controller. And number eight, this is our workflow look like end to end. We got a main. Inside main, we got a ride controller. Inside that, we got a ride service. That will go for my ride slash user slash vehicle. So this is my controller slash orchestration logic. This is my implementation. This is my entities. Okay. All right. I think we are good here. We can move to the code part of the solution demo part. And then this will take some time. And then we can come back to what are the resources in terms of case studies. Okay. All right. Let's quickly go back to IntelliJ. Let's see how the code is implemented, and then we can take up any or questions or something like that. So the way that I've done is I've kept majority of the logic in the drive class to create the user and stuff. So In the logic class, you see earliest ride, fastest ride, ride service, and user service. In the model, I have a ride, user, and vehicle. I'll walk through it one by one. Starting with my driver class. There you go. There we go. This is the input. So here I'm creating the user. I'm creating the user. Let's go to the user class. In the user service, I have a function written as create users. So if you go to the user model, this is what I've defined on a user. I define the name. Number one, this will be a string ID, which will be a UUID, unique identifier to every user. There will be a string name. There will be a character gender, M or F, because that's given in the input. Integer range, and that will be the list of vehicle. Why list of vehicle? Because one user can have multiple vehicles. Then the number of ride taken, number of ride offered. And that is all I'm initializing. When I'm creating a user, initially these values will be 0. The rest of the values we're already getting from here. And IDs that we are generating randomly. These are the getters and setters for this one. Everybody clear on the user class first. Anybody has any doubt in the fields that I have kept? IDs for unique identifier, name, gender, age is already given. List of vehicle because multiple vehicles. Ride taken, ride offer, we need to know about for every user. That's why I've kept this. Everybody crystal clear for the user model. So add vehicle is nothing. Add vehicle is just for adding a vehicle to that list. This dot vehicles dot add v. So we have a list of vehicles, right? So if a user has multiple vehicles, we can add more vehicles into it. That's why the function add vehicle. Okay. All right, guys. This was the user model. Let's go back to the source and destination of user. Source and destination we don't need from the user side. Source and destination we need on the right side. Correct? If you look at it, if you look at the input as well, if I add the user, so in terms of adding a user, I need the name, I need the gender, I need the age, and I need the vehicle part, add underscore vehicle, right? Ride is something different. Ride logic should be kept at the ride logic where we talk about source, destination, stuff. But for a user, keeping a source and destination doesn't make sense because user can change for multiple rides, right? So source and destination will change over a period of time. That's all. Okay. That was my user model. Now coming to the ride model. Or before that, let's cover the vehicle model. In vehicle model, I have the vehicle ID here. That's the registration ID. I have the owner, who is the vehicle owner, who is the model number, and what's the registration number. I mean, model in the sense, what is the car and what's the registration number. So if you look at this, in terms of add a vehicle, we got the owner, we got the model, which is Swift I'm calling, and this we got the registration number. ID is just a unique identifier. Unique identifier for every vehicle. We are generating it as a UID. This part. Okay. These three details we get from the input. This one we populate by ourselves. Okay. Now coming to the ride part, let's talk about ride also. What do we need in the ride? We need the ride. Who is the ride giver? Who is the giver vehicle? What is the number of available seat? What is the origin? What is the destination? What is the start time? What's the ride duration? So if you look at any ride example for, let's say, I think this does not contain ride example, but let's consider this ride example. So in this offer ride, we have the ride giver, origin, available seats, vehicle number, destination, start time, and the ride duration. All of those things I have put it in my ride class. Everybody crystal clear with the models, user, vehicle, and ride. Come on, guys, be quick in the chat. User, vehicle, ride, models are crystal clear. Okay. If models are crystal clear, go back to my driver, then I'll come to the implementation logic for logic classes. So in my user service, I create a user. I'll walk through that. What is that user service? Or you can walk through right now also. In that user service, I'm just creating the user. So I create a user. What I'm doing as part of this create user, I create this new user object based upon this user model that I just showed you about. So I can add vehicle to the user, this that vehicle part, and so on and so forth. Okay, get vehicle by registration number, get vehicle by name and registration. All those details are there. So first thing first, I add a user one added, and vehicle one added by add vehicle. User 2 added, vehicle 2 added, user 3 added, it does not have a vehicle, user 4 added, it has multiple vehicles, right? So we create vehicle 1, vehicle 2, so on and so forth. And then user 5 added. So that is taken care till the user service part. Okay, one moment, guys, let me complete the code first. Now, when we go to the ride service part, let's go to the implementation logic of ride service. So in ride service, if you look at it, I've kept a list of all the rides. This is my list of ride which contains all offers. What I'm doing is I have two major functions here. One is offer ride and second is a select ride service. So for offer ride, what's the logic that I have kept? For offer ride, we would have the string name, we would have the registration number, the number of available seats, origin, destination, start time, and duration. This is the same function when we talk about offer ride here, this part. Okay, 2 comma ABCD, this part I'm referring to. What do we have in this part of 2 comma ABCD? So I defined a user, which user by name and registration number, I'll get which user to provide. If that user exists, right? User that exists, I'm checking by name and the registration number. So I'm printing user has no such vehicle, so cannot offer such ride. So you can only offer ride if provided a user has a vehicle. Okay. One moment, guys. I'll answer that. Let's go to the logic first, then I can answer all the question. First thing first, when we talk about offer ride, ride can be offered by the user which has a vehicle. So first thing that I'm checking is if user have no vehicle. So I've written a function called user by name and registration number. So in that name and registration number, I'm comparing whether the user is the owner or not. Okay. Going back to this. So in my ride service, I'm checking if the user does not have a vehicle. If the user does not have a vehicle, in that case, user cannot offer a ride. So user exists, user has a vehicle, fine. Now we get the vehicle, which vehicle the user has. Now we're checking the date format, converting into English. You can do it by based upon whatever pattern you want. I'm parsing the date. Here I'm creating a new ride. So in this new ride service, I'm creating, go to the implementation. Who is the ride giver? Who is the giver vehicle? Who is the available seats? Origin, destination, start time, ride duration. All of these details we are getting in the input. Okay. After that, we are setting the ride offered is set ride offered plus once because whatever number of ride offered by that user previously, now that will increment by one. By default, it will be zero. And I'm adding it to the all offers ride. So set ride offered, distort ride offered equal to ride offered plus one. Okay. This was the implementation of offer ride. The second implementation is selecting the ride service. So for selecting the ride service, there can be two parts. Either it can be fastest ride or it can be earliest ride. So we take the user, we take the origin, we take the destination, we take the type. So if you look at question 2, you take the user, origin, destination, and the type. That type will determine whether it's earliest or what's the strategy, earliest or fastest arrival. So if I look at this, first thing first, if I'll get all the available rides with source and destination. So if there is no destination provided, or there is no source provided, from that source to destination, if there is no particular ride, I can put the values null here and I can print the output that there is no ride available for such use case. Now I put a switch condition here. First, if it's a fastest ride, I'm calling the function for fastest ride. If it's the earliest ride, I'm calling it for the earliest ride. Okay. So in order to do that, this is the past of earliest and fastest, which I'll come to a bit later. So in terms of select ride, what we are doing here in the first place is if that becomes null, user is not there. If no such ride is there with the source and destination, that's where we are printing it. We're marking the seat of available seats. We are checking whatever the all rides are taken. Once the ride is successful, we say ride is given by this with vehicle to this user. Okay. And this was the logic of available with source and destination. This part I told about should not have same user, should have same source and destination, should be having available seats. These are the three validation checks. First, it should not be the same user who is giving the ride and the destination. Number two, it should not be the same source and destination. Number three, it should have available seats. So all those three conditions are available. The validation that we talked about. Okay. Then we have the logic for fuel saved by user, whatever number of rides, we are just counting by ride duration, and that ride duration will be total number of fuel saved. So that's a pretty straightforward code. Okay. Now coming to the interesting part, what is the earliest ride and the fastest ride? Earliest ride logic, how do we compare the earliest ride logic? We just take the start time compared to the get start time. That will be the earliest one. And when we talk about fastest ride, what do we need to do? We need to reduce the duration to compare which is the fastest one. That's it. Okay. Now let me know, guys, what are the questions? Okay, add vehicle code. Let me show that add vehicle code. That would be in the right. Let's see that add vehicle code. One moment. This is the add vehicle code that you are referring to. Okay. What else? How did you manage relation between vehicle and owner? Good question. See, in terms of vehicle and owner, if you look at the vehicle class, I have the string owner. That's how I'm managing the relation between vehicle and owner. Okay. Show the comparison logic that you've done in ride service. Comparison logic for what? Comparison logic for earliest and fastest, or what's the comparison logic you want to see? So this is defined here. So earliest ride, I'm checking based upon the start time. Okay. And fastest ride, I'm checking based upon the duration. Okay. Cool, guys. Any more questions? Switch case and ride service. Okay. Yeah, this is a switch case. I'm calling this fastest ride here. I'm calling this earliest ride here. And from that array with the list of all the rides, I'm taking the first element. Okay. This is the earliest logic. We compare based upon the start time. Earliest means whenever the earliest ride is starting. So we're just comparing based upon start time. Those two are the comparators. Yes. I mean, you pass two rides, right? See, the logic it is written in such a way, you take all the rides, compare across, let's say there are 10 rides. You compare across the 10 rides, you check which one is the earliest arrival or which one is the fastest arrival, whatever the logic is. And then you take the first value out of there. That's how the logic is kept. Okay. All right, guys. Any more questions? Any more questions? Anything else? Cool. Let's go through the demo real quick. Let's see how the code is working. So I was here till actually part. So first thing first, we defined for the ride service, we created the first ride, we created the second ride, third and fourth. And then we talked about the ride which was requested. So this was requested, select ride, select ride, select ride. And then we print what are the fields shared by all the users and per users. So let's run the code. Let's go through the output and see if it's matching our expected output or not. So the expected output was, let me open that expected output from README as well. So first ride is given by Shipra with vehicle K0414 to Nandini. That is correct. Then Shipra with 12332 to Gaurav. That is correct. No such ride present from Mumbai to destination Bangalore. That is correct. And type was fastest ride. That is fine. Ride is given by Shashank with vehicle ID to Rohan. This is correct. Total fuel saved by Nandini was 4. Gaurav was 10. Rohan was 14. That is also correct. Rohan has taken 1, offered 1. Shashank has taken 0, offered 1. 1 and 0 for Nandini, 0 and 2 for Shipra, 1 and 2. This is fine. The code is working as we expected. Okay. This will pass all test case, and that's all you need for this one, for this case study specifically. All right, guys, that being said, let me know any doubts, any question. I have completed from my end. I'll take the last five, not 5 10. I'll take a couple of minutes to go through other case studies. Yes, this code will be shared. I'm not sure if this code I need to share. I'll share the problem statement for sure. Give me one moment. If I have that. Okay, cool. Good question. How can we handle concurrency in this? I'll come back to here. As of now, we don't have the immediate requirement to handle the concurrency. That's option requirement for sure. But to answer your question, how can we explain handle concurrency? Let's talk through it. Threading and concurrence is a big topic. I'm not sure if we'll be able to complete by now, but I can talk about what we can do in this case. So let me go step by step. Okay. Whatever we need for terms of requirements, we did it. In terms of option requirements, let's say you got concurrency handling, right? So concurrency handling here in Java specifically talk about in multi-thread environment, I can use synchronized and volatile keyword. So synchronized and volatile, they can be implemented on a class level, they can be implemented on a function level, right? Depending upon what kind of thread locks that you want. It's good to implement at a function level if you want more granularity. If you want to keep it on a high level, you can keep it at the class level as well. Okay. Depends on what you want to make a class synchronized or do you want to make a method synchronized. So to answer the question immediately, if you have to handle concurrency or race condition, we can use synchronize and thread keyword. Okay. And this I will keep where I'll keep it in the select ride method. Why select ride method? Because the only concurrency which will happen in this case study is when two people are trying to select the right at the same time. So I'll keep that logic at the select right method. Okay. And the concurrency case I'm talking about is when multiple people try to book the same ride at same time. That's all. Okay. Yeah, I'll share the code, guys. You can go through it. But let me see. Ride service. This is the all rights taken, which is a user, and there's a list of all the rights which has taken. That is what this map is. Okay. No, I think that's an incorrect topic given. That was the case study, and that's the last class. We will not be, as per my understanding, we will not be covering any more thing. This is the last session of the class. Okay. I want to cover, because we have less time, I want to cover something important, which was the important parts for HLD, LLD, and these parts. Let me take care of that. Okay. Let me see if I got it. Okay, cool. Let me come back to Sublime Text. I want to spend time on this one before we wrap up the session and stuff. User and list all rights CSC has taken. Yes, we provide that in the map. Consistent hashing is not part of low-level design, it's part of the high-level design. Okay. All right. Coming to this part, the final resource sharing. Let me cover to this. Okay. So as part of the case study, whatever the case study that we have done so far is, we have done with splitwise. We did snake and ladder. Chess I have given for homework. I'm not sure if how many of you have completed. One moment. Multi-parking lot we have done in the last class, and ride share service we did today. So total 4 plus 1 if I count as homework, that is the machine coding round or case studies we have done. Now, as part of the resources, what's a good resources to do for the machine coding round and all such? There's a good coding challenges given by John Cricket. You can just, I think I'm not sure his website name precisely, but it's just clear like even if you search on Google up coding challenges by John Cricket, they're really good case studies where you can actually practice your implementation skills for machine coding round. And these are pretty much similar to it. For example, like JSON validators, CLI interaction, parsers. So he provided, I think, 10 to 12 challenges. You can try those one. That's a really good resource to start with the machine coding round. And coming to the actual interview questions, the actual interview question, obviously you have the lead code discussion section to go for what kind of actual questions were asked as part of the coding interviews, and of course blind as well. Okay. In terms of high level design, those of course it's a mixed batch. So some of you have not completed high level design with me. Those who have not completed high level design, you will start after the low level design, which is this after this class. And those who have completed, I'm just quickly revising. The categories are usually in 5 or 6 categories. First category can be messaging app, which includes WhatsApp, Messenger, Telegram, etc. Second category is a cloud storage system, so Google Drive, OneDrive, all of those things. Third category can be streaming or storage services, for example, Netflix, Hotstar, and YouTube. Fourth can be the payment systems in terms of any kind of payment systems. Fifth can be the cab systems like Uber, Grab, Ola, or anything. And last can be the social media, which is Facebook, Instagram, etc. Notification systems are asked, but not as much, but you can add it to the list here. But these are the major categories on which it is asked. Okay. Usually, I have not seen an interview question asking only the notification system because notifications are part of the bigger product, right? So they might handle how do you handle the events, how do you take care of the notification that could be asked there. But I have not seen any question which is asked completely on the notification system unless there's a specific use case for it. Okay. And for the low level design, we have already covered this and I've shared the resource if you want to check more for the low level design part. Okay. All right, guys, I have covered pretty much everything that I need to from my end. I'm actually a bit delayed than I was hoping to wrap up this session by 2:40, but we are already 12 minutes late. Any other case studies for LLD? So these are we going to cover in class? No. These are the all cover case studies that we already covered in class. But in terms of resources, these are the ones. There are more than 10, 12 resources. You can try it for this. Yeah. You can refer here. You can take for these 10 to 12 resources. If you complete this one, there's a coffee design also, which is a popular case studies. So if you just read about this one, that will give you more idea what kind of questions can be asked. Okay. And one thing for the actual interview question, do check in the lead code discussion section. Filter it by the machine coding. You will know what kind of questions are asked. Of course, you will not get the same interview question for sure. For example, the one that you have seen was actually asked in the company. So you will have different questions for sure, but if you practice these kind of challenges and the 4 or 5 case studies that we have covered, that will give you enough confidence that you can write the code in 2.5 hours, whatever time is reasonable. Okay. Lead code system design, is it good? What do you mean by lead code system design? I mean, the design question of designing lead code, is that what you're asking? Or it a course on lead code? I don't understand what lead code system design. I have not checked it out, so I cannot comment on that. No, I have not checked out the course on lead code, so no idea upon how good is that. But lead code is good for obviously getting out the question, what was the question asked, and practicing the DSA problems. System design, I'll let the other websites and good resources to take care of that. But again, I've not seen the course. It might be good, might not be good. I have not personally reviewed it. Okay. All right, guys. I think I've shared the resources that I have from my end, and we've completed this case study as well. So I'll quickly go through the revision and then we can wrap up the session. So for this part specifically, we focus on the fourth and the final case studies, which has been actually asked in the interview. We talked about the requirements first. What are the expectations? What are the test cases? What are the outputs? So on and so forth. Then we talked about the solution in terms of implementation, where first we go through the expectation, what clauses we need, what entities we need, services, driver class, logic, validations, etc., etc. Okay. Then we talked about the general flow. We start with the entities models, we read services, and then we go for the logic for the driver class. This is our workflow. We've gone through the solution demo in detail. We also talked about the option requirement for concurrency handling. Finally, in terms of the resource sharing, these are the case studies that we have covered so far as machine coding. There are some other important case studies also, which you can check by these coding challenges, which are really good. And in terms of actual interview question, one moment. In terms of actual interview question, you can stick to the lead code discussion section or the blind part. In terms of HLD, these are the major case studies which can be asked in interview. And for LLD, these are the major ones which are asked in the interview, just for your reference. Okay. And of course, feel free to filter by most latest one, which is asked on lead code. So that gives you more insight in case there's a change in the interview pattern. Okay. Now we don't have any session for tomorrow, at least not on my calendar. HLD will start. I don't know when it will start. I'll be on vacation from tomorrow. So I'll come back after 1 month. Maybe there is some other instructor who will be taking HLD for those who have not covered HLD. So as of now, on my calendar to your question, there's no session for tomorrow for HLD. Okay. This is the last class for low level design that we are ending today. And that's it. Okay. All right, guys. Anything else on this low level design course? Anything on today's case study specifically? Okay. All good. That being said, guys, let's wrap up the session and let's wrap up this course as well. We have gone through, I guess, 8 plus 4, 12 total, well, 11 to 12 classes that we have total completed. Okay. All the best for your low-level design interviews and high-level design as well. Those I have already revised. Revised in the sense I've already completed with. In case any questions, feel free to reach out if you have any doubts for HLD or LD in general. And all the best for your upcoming interviews as well. Okay. Yeah, that's what I'm saying. For HLD one, I don't think you need to wait for me to come back. I think there would be some other instructor. I don't have the time when your batch will be starting. Your course coordinator will have better insights. As of now, I don't have any information about any HLD course starting. I'll see that after 1 month because I'll be on vacation, so I don't have any particular schedule as such, but I'll check back. But I think if it is starting in less than 1 month, then it would be some other instructor. Okay. All right, guys, let's wrap up the session here for today. Let's all the best for your upcoming interviews and slash mock interviews. And feel free to reach out in case of any questions. Okay. Thanks for joining in, guys. Have a good one.